We're taking a look at the kinematics review problems. This video is going to go over the answers to numbers 1 through 4. Number 1, in getting ready to slam dunk the ball, a basketball player starts from rest. That means the initial speed is going to be 0 meters per second. And they sprint to a speed of 6 meters per second, so that's going to be their final speed, the speed at the end of the problem, in a time of 1.5 seconds. So I've listed all those numbers in the correct spots here. Now, assuming that the player accelerates uniformly, meaning they have a constant acceleration, determine the distance that the player runs. So we're looking for d, so that's my question mark. So I go to my 4 kinematics equations and I look for the one that does not have acceleration in it, and that's the d equals 1/2 vf plus v naught multiplied by t. It's already set up for the variable that I want, which is d, so I can plug in my numbers. 1/2 times 6 meters per second plus 0 times 1.5 seconds. Plugged it in my calculator and I find out that he must have run 4.5 meters. Number 2. A VW Beetle goes from 0 to 60 miles per hour. Now we don't use 60 miles per hour, we're going to use the 26.82 meters per second that are given right next to that because we always use metric when we're doing physics problems. But it starts from 0, so the initial speed is nothing, and the final speed is that maxed out 26.82 meters per second, with an acceleration of 2.35 meters per second squared. So A, how much time does it take for the Beetle to reach that speed? So that's the first question. And B, a top fuel dragster can go from 0 to 60 in 0.6 seconds. We're going to find the acceleration of the dragster, but that's going to be the second part. We're going to take a look at the first part, and what we need is to find t. What we don't have is the displacement. We look at our equations, which one does not have d in it? That would be the vf equals v naught plus at. We're going to rearrange this for time by subtracting my v naught over to the other side and then dividing the acceleration over, which is why I get vf minus v naught divided by a. Plugging in my numbers, I just have to plug in the 26.82 meters per second minus 0, all divided by 2.35 meters per second squared, and I find it takes the Volkswagen 11.4 seconds to get to 60 miles an hour. Now we're going to take a look at the dragster. It also starts from rest, is reaching the same final speed of 26.82 meters per second. It just does it a lot faster at 0.6 seconds. So we want to know, well, what's the acceleration? By comparison, the Volkswagen had 2.35 meters per second squared, so what does the dragster have? We're going to be taking a look for A. We want the equation that does not have d in it. That would be vf equals v naught plus at. We're going to be rearranging for acceleration this time. So we still subtract the v naught term to the left first, and then we're going to divide the t out. So vf minus v naught all over t. We plug in our numbers, and that's going to give us 44.7 meters per second squared. Moving on to number 3. You are driving down the road at 24 meters per second when you see a deer up ahead. So our initial speed is 24 meters per second because that's how fast we're moving at the beginning of the problem. You slam on your brakes in an attempt to stop before hitting the deer. If you slow with an acceleration of 5.3 meters per second squared, well, you're slowing down. So if your initial speed is 24 meters per second positive and you're slowing down, your acceleration is going to be a negative number. So how far do we travel before we come to rest or stop? So we know that we're stopping, so our final speed is 0. And we want to know how far we're going, so D is the question mark. Time is the one we don't have and we don't care about. So I'm going to take a look what equation does not have time in it. That's the vf squared equals v naught squared plus 2ad. We're trying to solve for the displacement. So we're going to subtract the v naught squared term over to the other side first, giving me vf squared minus v naught squared. And then we're going to divide the 2a over to the left. That's why it's in the denominator here. Once we've done that, we can plug in our numbers. 0 squared minus 24 squared all over 2 times negative 5.3. This negative is very, very, very important. If you forget it, you're going to get a really weird answer. And what you find is that we go 54.3 meters before coming to a stop. And number 4. You are designing a runway for the Reading Airport. You need to accommodate planes that need to reach a takeoff speed of 72 meters per second. That's how fast you're going at the end of the runway. So the planes are going to be accelerated at a rate of 2.5 meters per second squared. How long does the runway have to be? D is a question mark. Well, the initial speed, this is one where the number is not given in the problem, but we just have to think to ourselves, well, how fast does a plane go before it even starts to take off? And that would be 0. It's not moving and then it accelerates to get to its takeoff speed of 72 meters per second. So I'm going to be taking a look for the equation that does not have time in it because it's our blank spot, which is Vf squared equals V naught squared plus 2AD. We're solving for the D, so that means we're going to subtract V naught squared over to the left, which is why it's Vf squared minus V naught squared, and then divide by 2A. Plugging in our numbers, 72 squared minus 0 squared all over 2 times 2.5 gives us 1,036.8 meters for the distance the runway needs to be.